Alright, like I said, today's lesson should be more of a refresher rather than you seeing the material for the first time. We're going to talk about complex numbers, okay? First of all, complex numbers are the combination of the real numbers and the imaginary numbers. And imaginary numbers are anything that contains an I. If you remember from Algebra 2, I equals to square root of -1. Okay? Yes, sir. Yes. Okay? Alright. One thing you have to remember is that complex numbers have a standard form. The standard form of a complex number is a plus bi. Okay? Where a is going to be the real part and bi is the imaginary part. Your answer should always be on that form. The real part first, plus or minus the imaginary part second. Okay? If two complex numbers, let's say a plus bi and c plus di are equal, then that means that a and c would have to be equal and b and d would have to be equal, correct? Do we all understand that? That's the only way that this could be true. If a and c are equal, then b and d are equal, then that means that both of those complex numbers are equal to each other. Okay? Alright. Little refresher about how we can use I, and because today we're going to use complex numbers to perform operations such as addition, subtraction, multiplication, division, etc. Okay? Alright. We all know that I is the square root of -1, correct? So, I squared would be the same thing as saying square root of -1 squared, which simplifies to be simply -1. I to the third power, we can break it down to say that it is I squared times I, and by now you know that I squared is -1, and well, I is I, so -1 times I is -I. I to the fourth power, we can break it down to say I squared times I squared, and by now you know that I squared is -1, so -1 times -1 is 1. I to the fifth power would be I to the fourth times I. By now you know that I to the fourth is 1, and I is just I, so 1 times I is I. And this can continue going on and on. Okay, do you guys see a pattern? So you go I, -1, I, 1, I. So what would you expect I to the sixth power to be? I to the seventh power. And so on, correct? Alright. What if I was to ask you, what is I to the 73rd power? Okay? Alright. You could try to do it one by one and try to go until you get to 73rd power, right? But that would take forever, okay? So there's a little trick that I use to kind of figure out what I to a high power would be, okay? First of all, do you notice that there's a pattern every 4 terms? So it's I, -1, I, and then, 1, and then I, and then it repeats again. So it's every 4 terms. So what you can do is you can take your exponent and divide it by 4. Okay? If your exponent ends up to be no decimal, so if you get a whole number, that means that the value just simplifies to be equal to 1. Okay? If you end up with some number with a decimal of 0.25, then it simplifies to simply be I. If you end up with a decimal that is 0.5, then it's -1, and if you end up with a decimal that is 0.75, you get -I. So for I to the 73rd power, if we try this trick, so if you do, 73 divided by 4, you get 18.25. So what does that mean? It's going to be I. Cool? Alright. Let's move on to what I care more about complex numbers. Really, that's not, to be honest with you guys, I'm not going to test you over that. That's just a nice little trick I've used, okay, to help figure out what I to a high power is, okay? What I really care about is that you can do arithmetic with complex numbers, okay? So, like I said before, you should be able to add, subtract, multiply, divide, okay, and actually take things, complex numbers to powers as well. So, when you're doing arithmetic with imaginary numbers, you're going to treat I just like a variable, just like you've done it with algebra, okay? and you're going to treat it as a variable, and you're just going to combine like terms. For example, we're going to pretend that a is 2 minus I, and b is 4 plus 3i. So if I'm doing a plus b, that's 2 minus I plus 4 plus 3i. You're going to treat it just as variables, so you're combining like terms. 2 plus 4 is 6. Negative I plus 3i is 2i. So your response is 6 plus 2i. If you're subtracting, you're doing the exact same thing. 2 minus 4, that's negative 2. And negative I minus 3, that's negative 4i. Cool? With multiplication, you must remember you still have to use the whole FOIL. You still have to distribute things out. So, if you do 2 minus I times 4 plus 3i, you're still FOILing out. So 2 times 4 is 8. 2 times 3 is 6, so that's 6i. Negative I times 4, that's negative 4i. And negative I times 3i gives you negative 3i squared. Alright, and if you remember, this right here is very important. Because I squared, you know the value of I squared. Or you should know the value of I squared. I squared is what? Negative 1. So you must make that substitution and combine like terms. Okay? 8, we're just going to leave the 8. 6i minus 4i is the 2i. And negative 3i squared becomes negative 3 times negative 1, which becomes a positive 3. So positive 3 plus 8 is 11 plus the 2i, so that will be your response. Alright, some of you guys are familiar with this, some of you guys are not familiar with this, so you can actually use your calculator to use complex numbers. Okay, so if you're not familiar with it, take out your calculator. First of all, if you go to mode, and you go all the way down to where it says real, you'll notice that next to real you will see a plus bi. If you highlight that and hit enter, that means that if you put anything with imaginary numbers in here, it will give you your response using imaginary numbers. Okay, so hit mode, go all the way down to real, and then highlight a plus bi and hit enter. So we can try it. Remember how we had on the example above, we had 2, and the I, by the way, the I is located, you see where your decimal is at? That's where the I is located. You're going to have to press second decimal. So if I want to do 2 minus I, so I would do 2 minus second decimal, there's my I, plus, parentheses, 4 plus 3I, close your parentheses. Your calculator actually gives you your response using complex numbers. Okay? Why am I showing you this? This will not be allowed on the test, but you can use this tool to help you during homework to make sure you get the correct answers. Okay? I'd just like to share that it is available. Okay? Alright. You can play with it while you're working on your own, but let's move on so we can kind of finish this notes today. Okay? One of the concepts that I would love for you to remember, if you do, it's the concept of a conjugate, which we've already talked about in this class. Okay, do you guys remember what a conjugate is? No one? So with the complex numbers, you're going to still keep your same real value and your same imaginary value, but the sign in between is going to switch. So for example, if you have a plus bi, its conjugate would be a minus bi. You only change the sign. This is very important. You only change the sign of the imaginary part. You do not change the sign of the real part. Okay? Alright. Does anyone really remember what's the whole purpose of a conjugate and how does it help you? It can get rid of what? The I. Okay? It can get rid of the actual imaginary part of it and just make it real. Okay? So, the whole purpose of the conjugate is to help get rid of I term. Okay? Alright. When you multiply the conjugates, every single time you will get, notice for example, if I take the a plus bi times a minus bi, a times a is a square, and bi times negative bi, that would be negative bi squared, but I squared is negative, so negative b times negative 1 makes it a positive b squared. That is true every single time. So there's a shortcut. You don't actually have to FOIL out the entire thing. Because it's a conjugate, every single time that middle term is going to cancel out. So for example, the conjugate of a here would be 1 plus I, correct? So if you do 1 times 1, that's 1. Negative I times positive I gives you negative I square. But negative I square is what? Positive 1, which is 2. Okay? This one, the conjugate would be 7 minus 6I. 7 times 7 is 49. 6 times 6 is 36. And because of the, I'm sorry, 6 times negative 6 would be the negative 36, but because you have the I square, it's going to make it into a positive, correct? So it's plus 36. So what's 49 plus 36? 85. So the conjugate again helps you get rid of the imaginary term, and now we're all on real numbers. Questions about conjugates? Okay. Alright, so then let's flip the page. Alright. We're going to practice some actual operations. So we have a lot. We have some division. We have some negative roots. We have some powers. Okay, so I want to make sure you're comfortable with doing this. I don't have any addition and subtraction because I don't feel like you need to practice for that. Okay? Alright, so it says in order to divide, to do division with complex numbers, you multiply the fraction by the conjugate of the denominator every single time. So you multiply the fraction by the conjugate of the denominator. Okay. And don't forget that I is square root of negative 1. And a radical cannot be in the denominator. That's the reason why we get rid of it. Okay, because technically your I, you having an I here means that you have a radical on the denominator, which is not allowed, correct? Okay, so for number 1, you're going to multiply by what? The conjugate of the denominator, which is 1 plus 2I. Both top and bottom. So I want you to actually go ahead and try it. And then pause the video if you're watching, and then come back and check the answer. Alright, so check your answer. You should have gotten 4 plus I for number 1. Alright, number 2, you have two fractions being added together with different denominators. So you must remember that to add two fractions, you must have common denominators. So I guess you're fortunate here that the denominators happen to be conjugates of each other. So in order to get common denominators, you're going to multiply each fraction by its conjugate. So on the first one, you'll have 2I times 2 minus I over 2 plus I times 2 minus I, plus the second would be 5 times 2 plus I over 2 plus I, 2 minus I. And just simplify from there. So on the top you have 2I times 2, that's 4I. 2I minus times negative I, that becomes negative 2I squared. And then you have plus 5 times 2 is 10. 5 times I is 5I. All over 2 times 2 is 4. And I times negative I is negative I squared. Alright, we're going to simplify all this. So we have 4I plus 5I, that's going to be 9I. And then the 2I squared becomes positive 2 plus 10, that's 12. Over 4 minus I squared, so that's 4 plus 1, so that's 5. So this becomes 12 over 5 plus 9 over 5I. Yes. Okay. You must separate them and keep them in the A plus BI format. Okay. Alright. Really, what I've been preparing you for is for when you encounter this. This is what you're going to encounter when you are dealing with polynomials of higher degree. And you're going to notice that something is not going to be factorable, and you're going to determine to either use the quadratic formula, or you can use completing the square, or use any of the methods, but you're going to get stuck with a square root of a negative number. Okay? Prior to this lesson, you could not take the square root of a negative number, but now you know that you can use complex numbers to accomplish so. Okay? would you guys agree that square root of negative 5 is the same thing as saying square root of negative 1 times the square root of 5?
Yeah.
Do you guys agree?
Yeah.
And you know that the square root of negative 1 is what? I. So wouldn't this be I times square root of 5? So that means that square root of negative 10, we can rewrite it as I square root of 10, correct? So now that we have converted into complex numbers, now you know that I square root of 5 times I square root of 10 would be I squared times the square root of 50, correct? Now, square root of 50, you should be able to rationalize that. That's 25 times 2, right? So the square root of 25 is 5. So that's 5 root 2. And you know that I squared is what? Negative 1. So that means this is negative 5 root 2. Okay? Alright. Questions over that? So let's try number 4. So number 4, we're going to have to rewrite this to help us out. So instead of being 2 minus square root of negative 6, we should be able to rewrite it as 2 minus I root 6 squared. Okay? Notice how I'm putting the I in front of the root. You don't have to. You can put it after the root. The reason why I don't put it after the root is because some students get confused and think that the I is underneath the radical, which is not true. Okay? So when you're solving this problem, you have 2 minus I root 6 times 2 minus I root 6. We're going to distribute things out. So 2 times 2 is 4. 2 times negative I root 6 becomes negative 2I root 6. Negative I root 6 times 2 becomes negative 2I root 6. And negative I root 6 times negative I root 6 becomes positive I square 6, correct? Or 6I square. So we continue to simplify this. This becomes negative 4I root 6. And this becomes minus 6, correct? So negative 6 plus 4 is negative 2. I had someone ask me, should I factor out a 2 and then have 1 plus 2I root 6? Don't do that. Leave it in the format of A plus BI. Okay? Don't factor anything out. Alright, last one, number 5. Okay? We're going to have, on the denominator, you have a third power. So 2 to the third power would be 8. And I to the third power would be I to the third. I just told you that you cannot have i's on the denominator. So, any suggestions? What do you think I should do to get rid of the i's? Multiply by I? Why not? So, if we multiply both top and bottom by I, then on top you have I, and on bottom you have 8I to the fourth power. Correct? Now, you don't have to memorize what I to the fourth power is. You should be able to deduce that I to the fourth is the same thing as saying I squared times I squared. Correct? And you know that I squared is negative 1. So wouldn't that be 8 times negative 1 times negative 1, which becomes I over 8, which you will rewrite as 1/8 I. Okay? Do you have to put the real part? Do you have to put 0 plus 1/8 I? You don't have to. Okay? Yes?
So can we put I over 8 or
You can leave it as I over 8. I'm okay with that. Okay? So just remember, you cannot have I in denominator. Okay? You cannot have it in denominator. Alright. I made a mistake again. I put the homework, but I didn't put the page number. Homework for tonight is page 133 and the following problems.